So my cat meowing makes me think of the Metro-Goldwyn-Mayer lion roaring at the beginning of a good movie. Well, anyway, we left off talking about reefs, living things in the oceans, building stuff. Well, we also do get sediment accumulating in the oceans. There's two main types of sediment that accumulate in the deep ocean basins. The first one is terrigenous. Terra refers to earth, so terrigenous comes from land. And because it comes from land, it mostly accumulates close to the continents. So if you look at my nice little map right here, the brown, I guess, brownish orange, I'm not good with weird colors. That's our terrigenous sediment. And you'll notice it's all concentrated right around the continents because that's the stuff that's being washed off the continents, carried to the oceans by rivers. Our other type of sediment is known as pelagic sediment. And pelagic sediment is stuff that settles through the water column. And this is mostly the skeletons of microscopic organisms. So there's different microorganisms and plankton and stuff that floats around in the world's oceans. And they create little shells or little skeletons of calcite or silica, quartz. And eventually those little organisms, they will die and they'll sink to the bottom of the world's oceans, and those little skeletons can accumulate and form sediment then. And so you'll see we have this calcareous that refers to kind of carbonate, calcium carbonate ooze, and silicious refers to the silica, the quartz that accumulates. And you'll see that tends to be in some of the places farther away from the continents where the terrigenous sediment tends not to accumulate. So just remember, two basic types of sediment in the world's oceans: the stuff from land that we call terrigenous, and the stuff that settles out of the water column that we call pelagic. All right, another neat thing that you'll see in the world's oceans near, especially near mid-ocean ridges, are something we call a black smoker. A black smoker is an underwater hot spring. And so if we're near the mid-ocean ridge, remember that's a volcanic mountain range, so we're going to have a magma chamber close by, and that's providing heat. And our seafloor rocks aren't completely solid. They're going to have little cracks and openings in them. So seawater can get into those rocks, can get heated up by that magma. And remember a rule I told you guys a few lectures ago: hot water holds more material in solution than cold water. So when this water gets heated up, it starts dissolving things out of the rocks like metals and sulfur, and then it rises up and it comes out as this underwater hot spring called a black smoker. And then once it's on the ocean floor, well, the ocean water is really cold, so it cools that water down quickly, and once that starts cooling, all of those metals and sulfur that's dissolved in the water starts precipitating and forming a massive sulfide deposit. Now, massive sulfide is simply composed of minerals that are metals bonded to sulfur that are precipitating on the ocean floor. These are very, very valuable mineral deposits that are created. So what's a black smoker look like, and how does it get its name? There's one. So this black stuff that looks like black smoke billowing out of that is actually very hot water. It's very black like that because it has so many dissolved minerals in it. Now you might be wondering what all this red stuff is here. Those are tube worms. Those are actually organisms that are specially adapted to live in this sort of environment. All right, the last thing I would like to talk about in lecture today is something called an ophiolite. I like ophiolites because they show us something we normally can't see on Earth. So an ophiolite is a slice of Earth's crust. It's a slice of the ocean crust. And let me finish this. It's a slice of the ocean crust that gets abducted, not abducted. We're not kidnapping it. But what abduction is, I've talked many times about subduction, where the ocean plate slides underneath or sinks underneath another plate. Well, that's not a perfect process. Sometimes bits of that ocean plate kind of get stuck a little bit and they get scraped up and added onto the continent. That's abduction. And so this ophiolite is this piece of the ocean crust that's being added to the continent and lets us see what the ocean crust looks like. And there are some distinctive layers to it. You usually have a thin layer of marine sediment. This is going to be that sediment that was accumulating on the sea floor. Underneath that, you get pillow basalts. Underneath that, you get sheeted dikes. Sheeted dikes are simply where you don't just have one dike, you have many of these intrusive igneous dikes basically kind of cutting across each other and forming on top of each other. Underneath that, you get gabbro intrusions. Remember, gabbro is the intrusive igneous equivalent of basalt. And then under that, you get peridotite, often metamorphosed peridotite. So what does this stuff represent? Well, think of the gabbro intrusions as a magma chamber, right? MC for magma chamber, right? That's where our magma is sitting. Now think of those sheeted dikes as the conduit where this magma is rising from the magma chamber. And then those pillow basalts, right? Basalt is the extrusive version of gabbro, and it's erupting on the ocean floor, and pillow basalt forms when we're erupting underwater. So those pillow basalts are where we had these underwater eruptions, and then the sediment is whatever accumulated on top of that. So we're kind of capturing how the ocean floor formed from these eruptions underneath the oceans. But then that brings into mind, what on earth is this peridotite down here? You guys remember the compositions of Earth's materials. The crust is either granite, if it's a continent, or it's basalt, if it's the oceans. And the mantle is made from peridotite. So when you see this area where we have the gabbro here, which is ocean crust, and you have the mantle material here, this is normally a time when I would be asking you, what is the name of the boundary between the crust and the mantle? And I know all of my students are going to remember the moho. So right here, this is the moho. And one of the reasons I like ophiolites is usually geologists can't visit the mantle. But in these ophiolites, we actually have little slices of the mantle captured and brought to us so we can actually study it. And that's what makes ophiolites special. So let's take a look at what these layers of the ophiolite look like. This is marine sediment. It's a little bit deformed, a little bit folded, because imagine the forces involved in subduction. Oops. These are pillow basalts. These are really old pillow basalts too. How old are these? 2.4 billion year old pillow basalts. So that's quite a nice little old piece of Earth's history captured there. These are sheeted dikes. You see that we have numerous dikes all formed there. That's what the sheeted part means. It's not just one, it's many of them there. And right here, this that I'm leaning against are some of these mafic gabbro intrusions, but what I'm standing on is peridotite. So I'm standing on what was once the mantle of the earth. And so right there, I am standing on the moho. And that's also your random picture of the day. So there you go, deep ocean basins.